Imagine a young basketball player practicing free throws. He's still learning, so his free throw success rate is just 20%. Now, what's the probability that his first successful free throw will happen on his third attempt? To figure this out, let's break down what needs to happen. For his first success to occur on the third attempt, he needs to miss the first two shots and then make the third one. The probability of missing a shot is 1 minus 0.2, or 0.8. So, the probability of missing the first shot is 0.8, and the probability of missing the second shot is also 0.8. We multiply these together because both events need to happen one after the other. Then, the probability of making the third shot is 0.2. So, we multiply the two misses by the success, giving us 0.8 times 0.8 times 0.2. This equals 0.128, or 12.8%. That's the probability that his first successful free throw will happen on the third attempt. Now, this problem is actually a perfect example of something called geometric distribution. You see, whenever we're dealing with a situation where we're interested in the first success, like in this case, the first made free throw, we can use the geometric distribution to solve it more easily. Geometric distribution is all about finding out when the first success happens in a sequence of trials. You'll often see problems like this phrased with words like the first time, until the first success, or on the nth trial. The formula for calculating the probability in these scenarios is 1 minus p, all raised to the power of k minus 1, multiplied by p. Where p is the probability of success, k is the trial number when the first success occurs, and 1 minus p is the probability of failure. So let's apply this formula to our basketball problem. Here, p is 0.2 and k is 3. Plugging in the numbers, we get that the probability of the player to make his first successful free throw on the third attempt is equal to 1 minus 0.2 to the power of 3 minus 1 multiplied by 0.2. And all of these is equal to 0.128. And there you go, the same result, 12.8%. This just shows how the formula simplifies the process, especially when dealing with more complex problems. How about we solve another one? A factory machine produces a defective item with a probability of 2%. What is the probability that the first defective item is produced on the fifth attempt? Just like our previous problem, this is a geometric distribution scenario because we're interested in finding out when the first success, or in this case, the first defect, occurs. The key word here is first, which tells us we're dealing with a geometric distribution. Here, p is equal to 2%, or 0.02. The number of trials, k, is 5, because we're looking for the probability that the first defect occurs on the fifth attempt. Using these values, we get that the probability that the first defective item is produced on the fifth attempt is equal to 1 minus 0.02 to the power of 5 minus 1 multiplied by 0.02. Using your calculator, you will get approximately 0.0184 or 1.84%. And there you have it. Whether you're calculating the probability of a first success on a specific attempt or figuring out how many tries it takes, geometric distribution is a powerful tool for these kinds of first scenarios. Understanding when and how to apply this concept can make a big difference in solving these types of probability problems. If you enjoyed this deep dive into probability, be sure to check out the other videos in our probability series. Thanks for watching, and good luck on your exam.